Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh and salam sejahtera. Let's start our class today by reciting prayers and blessing upon Nabi Muhammad sallallahu alaihi wasallam. Bismillahirrahmanirrahim. Rabbi zidni ilman warzuqni fahman. Allahumma salli ala sayyidina Muhammad salatan taj'aluna biha min ahli ilmi zahiran wa batinan wa tahsyuruna bi ibadikas salihin fi dunyana wa akhrana wa ala alihi wa sahbihi wa barik wa sallim. Today we will continue our study on chapter 2 entitled Design of Building Electrical Systems. In this chapter consists of 7 subtopics, as you can read by yourself. So we will cover all these subtopics in this chapter. Okay, this slide presents the design team in order to build a building. So we have two teams, landscape architect and also we have the engineering team. So under the landscape architect we have two team, interior designer and also structural consultant. Meanwhile, under the engineering team we have civil consultant, mechanical consultant and also we have electrical consultant. Okay, in the electrical consultant is where we are in charge in this topic. Okay, the current slide represents the main important parts in building electrical system, which consists of utility transformer, main distribution panel and also panel board. Okay, this is the design methodology, which consists of architectural plan, assembly load data and calculate panel board ampere rating, which finally to the electrical schematic. Electrical wiring in residential building are following the electricity supply specification MS-IEC 60038 standard. In this standard, we have a single phase supply with nominal voltage of 230 with a range plus 10% and minus 6%, and also we have three phase supplies with nominal voltage of 400 with range plus 10% and minus 6%, and then we have the permitted frequency is 50 Hz plus 1%, and also the earning system type, which is TT system. Okay, this is the example of single phase metering arrangement in the DB board. So the single phase meter here represent the kilowatt hour meter. Okay, this is the three phase overhead incoming for three phase meter. So we can see the difference between the single phase and three phase from this diagram. This is the single phase group metering. We can see here we have 5 pieces of single phase metering. And then this is the three-phase group metering. We can see the three-phase metering is more complicated compared to the single phase just now. As we have done before, we have two types of supply voltage options. So the first option have this characteristic, such as single phase 2-wire 240 volt up to 12 kVA maximum demand. And then we have 3-phase 4-wire 415 volt up to 45 kVA maximum demand. And then we have 3-phase 4-wire city metered 415 volt up to 1000 kVA maximum demand. This is the characteristic of low voltage supply. And then we have 3-phase 3-wire and 11 kilovolt for load of 1000 kVA maximum demand and above. And then we have 3-phase, 3-wire, 22 kV or 33 kV for load of 5000 kVA maximum demand and above. And then we have 3-phase, 3-wire, 66 kV, 132 kV and 275 kV for exceptional large load of above to 25 MVA maximum demand. So this is the characteristic of medium voltage and high voltage. Okay, now we go to the demand estimation. So the range of maximum demand for domestic consumer subclasses of premises is as depicted on the table. So we can see a lot of type of premises with different minimum and maximum kilowatt demand. And then the range of maximum demand for types of shop houses are as follow. So we have single story, double story, 3-story, 4-story, 5-story shop house with different value of minimum, average and maximum demand. This is the example of summary of load details. So we have block A with 257 units, and then we have the essential block A, which consists of circulation block, multi-story car parking, lift tower, boost pump, water transfer pump, fire protection service with their respective quantity and load. And from there we can calculate the total connected load, demand factor and the maximum demand. So this is where you have learned in the previous chapter. So you can double check your understanding by calculate the total maximum demand, group coincident factor, maximum demand, and also total in kVA. Okay, now we move to the domestic electrical system design for building. The first is the type of electrical load source. We have lighting, we have ceiling fan, we have switch socket 13 ampere. This is the example of the switch socket with 13 ampere. So SSO is the short form for switch socket outlet. And then we have also switch socket with 15 ampere. So this is the figure of the switch socket 15 ampere. And then SSO. And then we have water heater. And then we have aircon. And then we have electric motor and also exhaust fan. So this is the example of the electrical load source. And then we have the portable appliances like TV, radio, washing machine, computer, etc. as the sub-load to the switch socket. And then we have the type of PVC covered copper cable. We have cable 1.5 square millimeter, red, yellow and blue colors for load source like lighting and ceiling fan wiring use. And then we have cable 2.5 square millimeter, red and yellow, blue colors for load source like switch socket 13 amp and 15 amp, heater and aircon. And then we have cable with 4 square millimeter, red and yellow blue colors for load source like electrical motors. And then we have cable 6 square millimeter for earthing purpose. And finally, the cable with 25 square millimeter for wiring between kilowatt hour meter and dB. Okay, this is the picture of the cable. Okay, for the types of dB, we have PVC types cover with plastic cover, and then we have metal clad cover with cover. And then for the rating of dB, we have rating of the single phase dB. For example, 30 amp single pole and neutral, and 63 M single pole and neutral. And then rating of the three-phase dB can be 330 M, 3 pole and neutral, or 60, 100, or 150 3 pole and neutral type. So this is the example of distribution board for residential, and then we have another example of distribution board for commercial. So we can see that the commercial distribution board is much complicated compared to the residential. And then in our design, we need to know the types of circuit protection components that we need to use. For example, we need to use switch fuse in the rating of 30M, 60M SPN. And then we need molded case circuit breaker MCCB, or we need to use earth leakage circuit breaker ELCB, or residue current circuit breaker RCCB. And then we need to use overcurrent miniature circuit breaker MCB. For example, the MCB have one outgoing for 10 lighting point or fan point, and then one outgoing MCB for 3 power point SSO 13 or 15M, and then we have one outgoing MCB for 1 aircon point. This is the example. Or we have one outgoing MCB for 1 water heater point. So this is the example of the circuit protection components. Okay. This is the rating for MCB, which you can read by yourself. So this is the example for single pole MCB. This is the double pole MCB, and then we have triple pole MCB. This is SP, single pole, double pole DP, and tri-pole is TP with their respective rated current. And then this is the rating for RCCB. So we can see that this is for 2 poles, I have 2 here, and then this is for 4 poles. Alright. Okay, this is the example how to calculate the domestic electrical system design for buildings. So calculation of connected load and maximum demand loads. So this is the load estimated watts. We have lighting point, we have fan point, we have SSO point with 13 ampere, we have SSO point with 15 ampere, air conditioner point, and also water heater point with the estimated watt listed here. So we have the lighting point with 100 watt with 10 nodes. So to know the total power, we just times the numbers times the estimate power. We have the value. Same goes to the SSO point, aircon, and water heater point. So when we have the total power, we can calculate the total connected load. And then in order to find the actual maximum total electrical load, we use the demand factor nominal value, which are 0.7. So power maximum demand is equal to power connected load times the demand factor. Let's say we have the power connected load like 5292 watt. So we times 0.7, the nominal value of DF, we have the power maximum demand of 3074.4 watt. So from the power maximum demand, we can calculate the maximum total load current for one phase. So we have this equation. So we rearrange the equation. We got the current for one phase. Maximum total load current for one phase is power maximum demand divided by volt times the cos theta, V cos theta. So we have the answer 23.1 amp. So this value can be used for MCB 32 amp single pole. And then from the power maximum demand, we can also calculate the maximum total load current for three phase. So we have this equation. So rearrange the equation. We got like this and calculate it, and we have 6.06 ampere, which can be used in the MCB 20A 3-pole. Okay, this is the basic electrical symbols layout. So we have the lighting point. The symbol is like this. Ceiling fan point, SSO, SSO for 13 amp, 15 amp, and etc. You can read by yourself. This is the basic electrical symbol layout. This is for TNB meter panel. We have cut out fuse and also neutral link, and then we have switch fuse. We have also ELCB or RCCB, and then we have MCB or MCCB, and also earth chamber. This is the symbol from the Energy Commission of Malaysia. Okay, this is the example of a single phase consumer electrical wiring schematic diagram. So from this diagram, we can see that we have the main switch here, only one. Okay, this is the example of a three-phase consumer electrical wiring schematic diagram. So the three-phase schematic diagram is much complicated compared to the single phase just now. So we can see here we have two types of RCD. One is for 63 ampere TPN, and another one is for 40 amp. Okay, this is the architectural plan. Example of the architectural plan for the electrical building system. Okay, this is the example of schematic diagram from ground floor. So we can see here from the ground floor, the schematic diagram is from the TNB kilowatt hour meter. And then, okay, this is the example of schematic diagram for the first floor. So from the schematic diagram, we can see that the power source is from the DB at the ground floor. Okay, that's all for today. See you next week. Assalamualaikum warahmatullahi wabarakatuh.